Assalamualaikum warahmatullahi wabarakatuh and hi. So for this video, there is for subject statistic, the AE23602. We will discuss the content in the problem-based learning project. So firstly, we come from group 1. So I will introduce my group members. Firstly, my name Harnisa binti Sri, my matrix number AA193047 and I come from section 8. Second, Nawal binti Muhammad Radi. Third, Nurul Najihah binti Abah Aziz. Fourth, Sharifah Azila binti Roslan, and lastly fifth, Zul Nazmi bin Zailani. So we will start the explanation with the introduction. So this is the introduction for this project. There is simple linear regression. The simple linear regression is used to model the relationship between two continuous variables. The objective is to predict the value of an output variable based on the value of an input variable. The regression analysis is used to predict the value of dependent variable based on the value of the independent variable. Second, it also used to explain effect of changes in any independent variable on the dependent variable. So the dependent variable changes in a response to another variable, there is output value or to be predicted. And then independent variable determines the value of dependent variable, there is input value or variable. So we go to the graphical method. There is scatter plot. A scatter diagram is simply a two-dimensional Cartesian plot of paired xi and yi values, where I is 1, 2, 3 or another number, there is n. From the diagram, we can have an idea about the kind of relationship between the two variables. So at the bottom of the slide, there is type of relationship. So we have three type of relationship. There is strong relationship, weak relationship, and no relationship. So to find the right relationship, you can see based on the graph. And then next, there is correlation. The correlation coefficient measures the direction and strength of the linear relationship between two quantitative variables. The correlation coefficient is usually written as R. So this is the formula for the correlation coefficient. There is R equal by SSXY divided by root SSZZ multiplied by SSYY. So next, there is linear regression model. Relationship between variables is a linear function. When the relationship has a linear or straight line pattern, the correlation provides a numerical measure of the strength and direction of the relationship. The straight line that best describes the linear pattern is called the regression line. The equation of the regression line predicts the value for the response variable y from the explanatory variable x. The equation for the regression line has the form. So this is the formula for the linear regression line. So y is the dependent, the response variable equal by beta 0. Beta 0 is the population. There is you can find at a y-intercept. And then beta 1, there is population slope. There is m keturunan. And then x is a independent explanatory variable. And lastly, there is plus a random error. So this is the formula for the regression line. So the formula is y equal by beta 0 plus beta 1 x plus random error. So that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Najihah binti Abdul Aziz. My number matric is AA191134. I am from section 8. So today, I would like to present for the PBL assignment for the Villa table. Okay, let's move on to Villa table. So, problem format. This experiment is aimed to investigate the motion of a toy car on a ramp, which to study the relationship between distance traveled by car in cm and height of ramp in cm also. Each group is free to decide the first height of ramp and ramp length. Students are advised not to use the same value of independent variable among group. Calculate the mean distance traveled by the toy car for each height and put it in table. Okay, in Fila table we have four different things, which is facts, ideas, learning issues, and action plans or resource needed. Okay, first facts. In facts, for facts, what we got from the problem format is free to decide the first height of the RAM and RAM length. Second, increment of RAM height is consistent with the data. Third, use same car throughout the experiment. Okay, for the ideas, first of all, we need to set up an experiment to get the data. Second, finding the best length and RAM for the height. Third, as for a reminder, not using same height for the RAM. 4. Getting the data. After getting the data, we have to calculate the mean for the distance traveled by the car. 5th, tabulate all the data in the table. And 6th, try to figure out the formula of mean calculation. 7, try to figure out the correlation and also scatter diagram of the mean. Okay, for learning issues, what is the distance that toy car can travel? Second, how fast the toy car can reach? Third, what is the best way of to measure the distance traveled of the toy car? Fourth, what are the best equipments to use for measuring the distance traveled by the toy car? Fifth, what is the formula used to get the mean and also to get the correlation? Okay, for action and plan or resource needed. First, set up an experiment by following the guidelines. Second, identify the best model of experiment by searching on the internet. Third, referring to the reference book, which is Engineering Statistic. Okay, that's all from me. Thank you.
Assalamualaikum and hai, nama saya Sharifah Azila binti Ruslan dan dalam video kali ini saya akan buat demonstrasi untuk projek based on learning ni iaitu PBL. Okey. Di mana kita akan ini merupakan height of RAM yang pertama saya. Dan ini adalah toy car dan kita akan membuat 3 kali percubaan. Okey. Okey. Satu untuk percubaan yang pertama. Okey, dan kita akan ambil pita pengukur dan ukur jarak travel by a toy car. Okey. Dan yang kedua, okey, kita akan ukur juga. Yang ketiga, dan bila kita dah ukur ketiga-tiganya, kita akan kira purata untuk height of RAM yang pertama lah. Travel toy car yang pertama. Okay, so kita akan tingkatkan ketinggian height of RAM ni. Okay. Okay. Percubaan yang pertama. Percubaan yang kedua. Percubaan yang ketiga. Okay, dan kita akan ukurlah menggunakan pita pengukur ataupun pita pengukur dalam sentimeter. Dan begitulah seterusnya kita akan meningkatkan height of RAM ini sehinggalah sebanyak 10 kali dan membuat 3 kali percubaan untuk setiap ketinggian itu.
Assalamualaikum, my name is Nawal binti Muhammad Radi with the number metric AA190201. So today I will be discuss the question given. So from the data measured by Sharifah Azila, we can use the height of the RAM and mean to find the answer for our questions. So let's move to the question number 1. In the question number 1, it asks to draw a scatter diagram of the mean measured distance traveled by toy car versus the height of RAM using Excel. So I generate this scatter diagram in Excel. As we can see that the x-axis is the height of the RAM and the y-axis is mean of distance traveled by the car, and this is the data scattered in the scatter diagram. Next question is, does the scatter diagram exhibit a linear relationship between two variables? Please write an interpretation of that diagram. So based on this diagram, I can say that yes, the scatter diagram exhibit linear relationship between the mean of distance traveled by the car and the height of the ramp. But we can see that some but not all the variation of mean of distance traveled by the car is explained by the height of the ramp. Next, for question number 3, it asks to calculate the linear correlation coefficient for the data and interpret the given answer. As I said earlier, x is equal to the height of the ramp and y is distance traveled by the toy car. So here I already list the y and x, and also y squared, x squared, and also xy. I also already find the sum for each of these in the Excel. So to find the correlation coefficient, we need to use the sample sum of xy and also sample sum of xx and also sample sum of yy. So first we need to find the sample sum of xx and yy and also xy. So I use this formula to find this sample sum, which is for xx. I use the sum of x squared minus with x times to the power of 2 divide with n. So here I get sample sum of xx is 387.964, while the sample sum for yy, I use the formula y squared minus with y to the power of 2 divided by n, and from this formula I got the sum of yy is 38,746.97. While for the xy, I use this formula, which is sum of xy minus with x times y divided by n. So here is the sample sum of xy that I got from this formula. Hence, for r, I use this formula, which is sample sum of xy divided with sample sum of xx times with sample sum of yy. So I got the correlation coefficient is 0.8924. Next, find the least square regression lines and sketch the line. So the regression line, we need to use the formula y equal to slope b1 times x plus with y-intercept. So to find slope, we need to divide the sample sum of xy with sample sum of xx. So here I got 8.9179 for the slope, which is the b1, beta 1, and for beta naught, which is the y-intercept, is equal to the y bar minus with slope times with x bar. So for the y-intercept or the beta naught, I got 59.87. So here's the least square regression, and this is the line for the least square regression line. So this is where I generate in the Excel. As we can see, I got the same with the what I calculate and what the Excel give is the same. Next is the predict the value of the mean measured distance traveled by toy car, where the height of ramp is 200 cm. So here we just need to substitute the value of 200 cm into the regression line, which is the 59.87 plus with 8.9184 times with 200. Here we can get that the value of the mean measured for when the height of ramp is equal to 200 is 1843.55. So that's all from me. Thank you.
Assalamualaikum, my name is Zul Nazmi bin Zailani. My metric number is AA191908. Okay, today I want to present about conclusion. Okay, in conclusion, our group discover a wealth of information based on the topic assigned. In this chapter, there are two methods that we learn. First is conventional method and second is correlation method. In addition, we may use the graphical method or scatter plotter to draw a depression diagram and regression line using Microsoft Excel. Okay, furthermore, based on the case study, we all must understand that how to solve this problem in order to apply in our daily life. Okay, in this experiment, we can define a relationship between the variable used. In this case, our variable are the ramp of the ramp height and the distance traveled by the toy car. Okay, we can assume that the height of the ramp increase, so the distance traveled by the car also increase. Our group determined that the correlation coefficient creates a perfect positive linear relationship between the variable using coefficient of determination. Okay, for the last, math also help us better in problem solving skills. It also help us think analytically and be a better reasoning abilities. Okay, it also help us to think logically about a situation. So that's all from me. Thank you.